Now, we're gonna talk about water in Surabaya. Based on World Population News 2022, Surabaya is continuously growth over the years. Currently, the population is continuing to grow at a rate at 1.2%. Therefore, Surabaya is the second most populous city in Indonesia. But the point is, there is no indication that the trend will change in the near future. This high population obviously causes many problems in terms of economic, environment, and social aspects. The city government has an obligation to provide sufficient water, transportation, and other basic needs. If this condition has not appropriately and comprehensively addressed, it will generate serious instability in multiple aspects. The most crucial aspects is water crisis in Surabaya. As the response to this current condition, we proudly present our research called 3D resistivity data modeling to identify aquifer geometry by qualitative analysis, field study, PDAM Surabaya Groundwater Conservation Area Pasuruan. The members of the group are Muhammad Nur Rifai, Evita, Risda, Damayanti, and Dika, Khulashotul, Lativa.
So we can see in the screen, it is one of them in the Surabaya city. We can get it in the Kalidagir that's located in the Makromo, Surabaya. And so, yeah, the water supply of Surabaya city is from the Brantas River. But it is not only in the Brantas River, but also we can the Surabaya city can get the another water reserve from groundwater. This is can so it is shown in the 17 springs located in the Pasuruan. And to enhance the quality and the quantity of the groundwater, we need to be a subsurface mapping of aquifer by using geophysical survey. So, why must geophysical survey? This is this is the goals of the geophysical survey. At first, to determine the existence of aquifer, distribution, and location. And second, it can help us to plan exploitation activity and doesn't interfere the equilibrium between the discharge area and the recharge area by looking for the distribution of aquifer in the subsurface. So this is the benefit of the research. One, it can be used as a reference to the next research for calculate the estimation of reserve. So it can be planned long-term exploitation activities by considering the geometry of the aquifer through the 3D approach. And second, can support the conservation of groundwater program in 3 areas to maintain aquifer for long periods of time. So, what is the 3 area? Here we go. The research location. So the 3 area are the Pelintahan, Durensewu, and the Karanjati, and the area is located in the Pasuruan. And the geological condition in the Pasuruan consists of alluvium, which is intermediate to slightly based material, and a flat area with a slope of 0 until 1% and height of 0 until 4 meters above sea level. And the stratigraphy of the research area consists of original Welirang volcano rock, which consists of breccia volcano, lava, breccia tufa, and the tuff. So this is the methodology. At first, we get the field orientation, and we can make design, and we can process data, and when it's error, we can repeat the previous step, and we can get the 2D resistivity section, and we can get the interpretation, and we can get the unconfined aquifer demarcation, and we can get the cross-section 3D resistivity pseudo-section. And after this, we can get the 3D resistivity model analyzed. And the last, this is the result. We can get the geometry of unconfined aquifer. So this is the geological method. In this research, we use one of the geophysical method. The principle of the method is inject electric current into the soil and to measure the different electrical potential response from material below the soil subsurface vertically. And this is the material resistivity. The material is have a different resistivity, and the material is consists of air, period, quartz, calcite, rockstar, granite, andesite, basalt, camping, sandstone, slate, sand, clay, groundwater, seawater, dry pebbles, and alluvium. And this is the earth material resistivity values. And the source it is from the Telford et al. 1990. Okay.
Result and discussion. Let's take a look at the picture. The first picture is 2D resistivity model of Duren Sewu Karangjati line 1. The color of the subsurface condition is shown at type 3 and 4. So the resistivity is about 90 ohm meter. The aquifer is located at 3 to 7 meters depth. The reservoir thickness about 3 to 13 meters. The second picture is 2D resistivity model of Duren Sewu Karangjati line 2. The color of the subsurface condition is shown at type 3 and 4. So the resistivity is about 100 ohm meters. The aquifer is located at 3 to 5 meters depth. The reservoir thickness about 3 meters. The third picture is 2D resistivity model of Pelintahan line 1. The color of the subsurface condition is shown at type 4 and 5. So the resistivity is about 104 ohm meters. The aquifer is located at 1.5 to 3 meters depth. The reservoir thickness about 5 to 10 meters. The last picture is 2D resistivity model of Pelintahan line 2. The color of the subsurface condition is shown at type 4 and 5. So the resistivity is about 103 ohm meters. The aquifer is located at 1.5 to 3 meters depth. The reservoir thickness about 5 to 10 meters.
Unconfined aquifer determination. From the model, we can determine that aquifer is identified with the blue highlight. Depth about 3 until 7 meters, thickness about 3 until 13 meters, and resistivity value 32 until 142 lithology layers. The resistivity measurements are more likely to predict for lithologies that become an aquifer. However, the availability of water influenced by the hydraulical system as well as the water and drain system, which are also affected by the vegetation cover on the surface and weather. Move to the next step. This is called 3D resistivity section. The section made by overlaying the two cross sections to the resistivity. To see how the relationship between shallow aquifer layers shown off is cross section to the resistivity. On this slide, this is 3D resistivity of Duransewu Karangjati. And on this slide, this is 3D resistivity on Pelintahan. The section showed that the continuity of the cross section of the aquifer layer is not affected by the fault. That can make water difficult to pass beneath layer that offers water source to the surface. This may result from lithology cell under it or other impermeable rocks. However, future investigations are needed to determine the subsurface feature with a depth more than 30 meters. The result of 3D model show that geometry of an aquifer has a different character. And this is the conclusion. Number one, Lintan aquifer geometry prediction show continuity with anticline geometry structure. That means is Lintan area has greater groundwater volume than Turansewu Karangjati. And number two, Turansewu Karangjati aquifer geometry prediction show anticline aquifer geometry, but there is no continuity of the structure. That means is Turansewu Karangjati groundwater volume is not greater than that in Pelintahan. So we can predict that groundwater in Pelintahan and Turansewu Karangjati are projected to support water supply for Surabaya, which Pelintahan has greater volume than in Turansewu Karangjati. Thank you for your attention and goodbye. Wassalamualaikum warahmatullahi wabarakatuh.